Okay, welcome to part 2. We have one last example. All right. A Manhattan taxi cab company studied the lengths of taxi rides and computed the following statistics in miles. Okay, so on average they had rides of 4.8 miles with a standard deviation of 4.2 miles, a median of 3.6, Q1 of 1.8, Q3 of 5.9, and an IQR of 4. If they converted the mileage measurements to kilometers, what will the summary statistics be in kilometers? This is a reason when you would actually scale data in the real world. And in order to do it, you would take every value, okay, and multiply it by 1.62. So to begin with, the mean of 4.8 times 1.62. Because remember, when we were up here, when we multiplied, everything changed. All of this stuff, okay, all of the median, standard deviation, range, and everything. So we're going to multiply all of it by 1.62, and here we get 7.78K. If we did the standard deviation times 1.62, we'd get 6.8 kilometers. If we did, oops, I got to go ahead and put my M back here. If we did the median and the quartiles, okay, we would get this. And all I'm doing is multiplying by 1.62. You may need to pause to write that down. All right, so that's just a standard scale. Notice that everything shifted. Here's something more real world. If the cost of a taxi ride is $2.50 plus $3.20 per mile, what are the summary statistics for the distribution? Okay, well, we can write a function, a cost function, so C for cost, where we plug in the miles that you go in the taxi cab, and it'll tell us how much you have to pay. Well, $2.50 just to get in the taxi. That's called the flag drop fee. Notice I left off the 0 because I don't really need it for math. Plus $3.20 per mile. Now we're going back to miles, so we're going to go back up to this original data right here. Okay. It says, what are the summary statistics for the distribution of the costs? Well, we have to think about it. What we need to do is think about what happens when we add or subtract to data. Okay, up here when we added a 5, a lot of stuff changed, but the measures of spread, the standard deviation, range, and IQR, did not. Okay, and so we are taking our value, we're going to multiply, and we're going to also add to it. We are going to ignore the adding for standard deviation and IQR because it doesn't do anything. The multiply and divide, though, does. So let's do everything but standard deviation first and see if this makes sense to you. We have this function. So if they went 4.8 miles, we plug the 4.8 miles into the function. Cost, 4.8 miles. That's 2.5 plus 3.2 times 4.8. And if we do that really quick, 2.5 plus 3.2 times 4.8, we get 17.86. So it's going to cost you $17.86 on average. For the median, if we were to do that, okay, we plug in now 3.6 because the median miles is 3.6. We get 2.5 plus 3.2 times 3.6, and we should end up with 1402. If you try that and it doesn't give you the same thing, it just means that my old notes were wrong. Okay, and you could do that the same for the quartiles. So you plug in 1.8 into the full equation, and you would get 8.26. I really should label that dollars. For Q3, plug in 5.9, and I should get 21.88, it looks like. Again, you may want to check me on that. But for the standard deviation, we don't want to include the addition of 2.5. So all we're going to do is multiply. So we're not actually sticking it in the cost equation. We're just saying, we're just scaling it. 3.2 times 4.2 with a standard deviation of about $13.44. You very well may have questions on this. Come to class prepared to ask them. Again, with the IQR is 4.1, and we're going to times that 3.2 times 4.1, and the interquartile range is about $13.12. Okay, so when you have to do any adding or subtracting, you can just use the full function. Everything that happened to it you can do to any data point. But if it's an actual measure of spread, you only want to do multiplication or divide. That ends our notes. Okay, make sure you have this done for tomorrow. So yeah, there obviously was lecture notes. And have a great day.